Hello, everyone. Welcome to this workshop. We're going to be going through and building a full stack mean stack application in about an hour and change. My name is Valeri Karpov. I'm a software engineer at MongoDB, working on sort of continuous integration software as well as node-related things, working on maintaining Mongoose and a few other node-related projects. A little bit more about me. I'm actually the person who coined the term mean stack back in last year, April 2013. I maintain a few modules that we're going to be using in this workshop quite extensively. If you haven't seen them before, you'll be familiar with them by the end of the workshop, things like Mongoose and OmniDI. I also contribute to a few things like the Node MongoDB driver and mQuery, which is sort of a query helper for MongoDB that Mongoose uses. There will be a little bit of AngularJS in this talk, so yeah, there will be a little bit of client things, but it's okay, it's server track, so we'll be sticking primarily to server-side things. But I've been using AngularJS since version 0.9.4 way back when, because my mentor when I was an intern at Google is actually Mishko Hevery, the guy who wrote AngularJS, so I've been using it for a very, very long time. I have a few production mean stack apps out there. And in previous development roles, I worked in high frequency trading. I was a CTO of Level Up. I've done a few. I've been around in the development community. General outline. So what we're going to be building is a full stack single page application called Lean Mean, which is going to be a food journal. It's going to help you count calories and basically enter in, I ate this much of this food. It'll tell you how many calories that is. For those of you who don't know, and just so we're on the same page, Mean it stands for MongoDB, ExpressJS, AngularJS, and Node.js. It's a fun little acronym that symbolizes the union of these really cool hip technologies. And some additional tools that we're going to be using. Browserify is a Node module that compiles Node-style JavaScript into something that can run in the browser. Make is a simple automation tool. OmniDI is a dependency injector for Node.js. It simplifies the life cycle of creating long-lived objects and services. Mongoose is a wrapper around Node.js and MongoDB. Makes it a lot easier to sort of deal with MongoDB. And we're going to be using MongoDB's text search and Passport.js for Twitter OAuth. Now, that sounds like a lot, so let me first demo what we're actually going to be building, just so easier to tell once you actually see it in action. So you're going to get something like this. It's going to be a little bit gaudy because I like gaudy things sometimes, but anyway, wait for it to log in. And so I can track basically what I have eaten on a given day, and it will give me calorie outputs. So this is, I guess, what I ate while I was on my flight a couple of days ago. And today I can enter in what I ate today. So I ate some scrambled eggs. Guess 1 cup is roughly accurate. And I had some, pink cooked salmon. And so that was my breakfast today. And all's saved, all's good. So here, there's another picture. And in addition to simply just building out this application, we're also going to dive into sort of how we're going to automate our workflow. Again, we have to use Browserify to compile some of the client-side code. So we need some sort of tools in order to make that easier for us. And to do that, we're going to be using Browserify and Make. And in addition to that, this is going to be sort of code that's built to actually be used as opposed to being a trashy hack. I haven't quite put this up in production yet, but I will sooner or later. And in order to make sure that our code is well organized, again, Browserify will help with that, as will OmniDI. So we'll dive into that. We're also going to have testing and benchmarks. And in the wise words of Kobe Bryant, this is an app that's going to try at least to have its big boy pants on. So step by step, this is going to be roughly an 8-step process. The simple steps are basically one, understanding the data set that we're going to use. So again, the actual data for typing it that you saw where I typed in, I ate some scrambled eggs. All of that data comes from a USDA data set that's available for free online that I ported over to MongoDB. I have a blog post available on that, which I will link to at some point in this presentation. And we will go and we will discuss sort of what is going on with this particular data set. And we're going to create and restructure our Express application in order to make sense for a single page app. We're going to build some models, build an API. We're going to build out the single page app routing. And we're going to unify the client, write some tests, and then do some authentication. And you can follow along with this on GitHub. GitHub.com/vkarpov15/lean mean nutrition sample, or the slides for this presentation are up on my SlideShare and my Twitter, so you can easily just click on that link and follow along. Each GitHub commit is pretty exactly step by step, minus a couple of later bug fixes that I had to tweak. But yeah, so it'll be fairly easy for you to, or hopefully fairly easy for you to follow along. But also, feel free to interrupt me at any time with questions, concerns, or if I'm going too fast or too slow. Yeah. So first step is just getting the data set that we need to build out this application. So we need to have things like calories and all of these nutrient facts that we need to build out this application, and it's available from the USDA's website. I ported this over to MongoDB, and if you download this presentation, you'll be able to basically click on that link, download the data set, and put it into your own MongoDB database using Mongo Restore, which is a utility that comes with your MongoDB installation that lets you take a sort of dumped file and put it back into your current MongoDB installation. And again, I also have a blog post about the data set that will explain in deeper detail what this data set actually is. You don't really need you don't really need a very deep understanding of what the data set is for the purposes of this presentation, but you're definitely more than welcome to go and dive in and explore it in more detail. For the benefit of this presentation, we'll go through sort of all the information that you need for building out this particular application. So what the data set looks like, basically it's organized into a bunch of food item documents. A food item is something that you might expect. It looks like this. There is bison, which is a nice type of meat that I like to eat. It has a description. There's an associated ID and food group that come with the data set, but mostly what's important here is that each food item has roughly has a human readable description that is unique. And in addition to that, there is an array of nutrients for that particular food and an array of weights, which are common serving sizes for that particular food. So you don't have to estimate, how many ounces are in 1 cup or something to that effect. Deal with all of the conversions. So what a nutrient looks like is slightly more complex. An individual nutrient has an ID, a description, and a tag name. The tag name is the USDA's official sort of short form for that particular nutrient, and the description is the human readable form for that nutrient. So what you can see here is that grass-fed cooked ground bison contains about 25 grams of protein per 100 grams of meat. And of course, these are organized in an array, which is helpful for MongoDB aggregation and sort of counting through things. And what weights looks like, relatively simple. There is an array containing an amount, a unit, and the amount of grams in that particular unit. So in this particular case, the one serving size that they have is 3 ounces, which translates to 85 grams for the sake of sort of 3 ounces makes sense to Americans, and 85 ounces makes sense to everybody else in the world and scientists. So what is a simple query that we can run on this data set? Well, here's an example of something that will be useful for us: is how many grams of carbohydrate are there in 1 serving of raw kale? It's a good little introductory baby step for what we're going to do with the food journal. So what we're going to do is say, okay, find me something where the description is kale, raw, and the nutrients is something that has the description that contains carb with, well, MongoDB has this wonderful little capability to use regular expressions in the shell. So that's just a JavaScript regular expression for lowercase carb, which is short for carbohydrate. And the result, you get 8.75 grams of carbohydrate per 1 serving of per 100 grams of raw kale. But of course, you don't want users to have to enter in kale, raw, because that's a bit of a pain. So thankfully, MongoDB 2.6 has a nice little feature called text search, which in layman's terms you can think of as essentially Google for your MongoDB documents. So I can type in something like grass-fed beef, and that doesn't have to match the description exactly. It doesn't even have to be a regular expression match. But MongoDB is smart enough to do text search in about 15 different languages and recognize that, oh, okay, there's beef, there's grass-fed, okay, and be able to sort of find relevant results with this text score field. Now, the API is somewhat unstandard. You'll see that this particular sort field is not quite what you would expect from MongoDB. There's this weird $meta thing. This $meta operator is essentially just, well, right now its only use is for pulling out the text score. And that's the way that we're going to sort, because if you don't specify you want it sorted by text score, it's just going to spit out documents in well, not quite a random order, but not a correct order. If you specify this score field, it will actually sort them by most relevant results first, which is what we want. And again, yes? Yeah. Oh, do you mean the dash? Oh, I don't think you actually need that there. We can run an experiment. That's actually a pretty good question. I don't entirely know the answer. So let's do b/2.6.1/bin/mongo db.nutrition.find text : search grass-fed beef. Oh, whoops. Yeah, sorry, I need a $. Actually, yeah, it doesn't seem to. Wait a second. Actually, yeah, it does find it. Sort of. No, actually, it doesn't. Darn it. Okay, that's unfortunate. We'll have to work on that one. I believe so, actually. That seems to be the case. I'm not entirely well versed on how the internals work, but it seems to not do the right thing in that case. So I'll investigate that a little bit more. Thanks for the good question, by the way. That's actually excellent. But anyway. So since we have static data, this is a wonderful use case for text search. Text search since it uses what's called a text index, it's often expensive to overwrite the index. But if you're only reading from it, everything is great. But in order to use this, you need to create a text search index from your shell using db.nutrition.ensure-index description text that will create a text index on just the description of the food item. You can again, this is pretty much all you need to know about this particular data set, but you're more than welcome to dive into it more. I have a, yes? Good question. So you have to create the index once. After that, the index is going to get updated every time you update a document. So if a document has to say change position on the disk, the index will have to be updated. But you can run the create index sort of offline before you start your application. So in this case, like I've already long since created the text index, and either way, it runs pretty quickly because the data set is pretty small by MongoDB standards. Also, so if you want to read more about this data set, again, here's another link to the blog post. But just worth noting that that in order to use text search and text search sorting with Mongoose, you will have to use at least Mongoose 3.8.9. Before that, Mongoose has a limitation where it can't quite do sorting by text score. So let's get started on actually building the web application, the fun part. So create an Express app. Probably have seen this before, but if you haven't, you need to install Express via npm, which is the node package manager. Npm install express-g, and then running express lean mean nutrition sample gives you a simple directory structure that looks like this. But with a single page app, this isn't exactly entirely the correct structure. You don't really need Jade templating. Again, you can have it, but it seems a little bit wasteful. So just junk the views folder entirely. We're going to also set up package.json in order to have our correct dependencies. So to set up but something worth noting about developing node modules is that package.json is not just for declaring your dependencies. It can also be a very powerful workflow tool, and sort of very successful npm modules will make it very easy for you to get up and running with the package as easily as possible by basically all you have to do is do a git clone to pull down the repository. Npm install gives you all the dependencies you need, npm test to run tests, and then npm start to start a server. And this is something that we're going to try to do as well because this is a nice open source educational repo and should be very easy for you to pull it down and get started. So whoops, that's a typo. Why does it say well, that should be package.json. I apologize. But so the package.json is going to look like this, which is a little bit on the small side. I don't know. Can you all read that okay? Nope. All right, good. Or not good, rather. Which case? Which step was this? Aha. Okay, that's probably better. So one thing that you'll notice here is I generally like to hard code version numbers of the dependencies for this particular or for my npm modules because, well, there's really very little reason not to. Typically, when you try to specify, okay, I just want something that looks like 1.1, you are trying to deal with the fact that sort of different modules will have to depend on that particular version of a module. With NPM, since each module installs its own sub-dependencies, there's really very little reason to not say, oh, okay, I just want exactly this version of a particular module. For example, more recent versions of Mongoose rely on a different version of the MongoDB driver, which is the MongoDB 1.3.23 installed here. But there's no conflict between the two. I have sort of two different versions of the MongoDB driver installed, and the right package is using the correct one. So these are the modules that we're going to use. We're going to use a slightly old version of Express, OmniDI for managing our dependencies, and we're going to have Passport and Passport Twitter for doing authentication. And yeah, if you see code that or I'll have to ask you guys because it's unfortunately very difficult to read the code as is. So I will make sure to zoom in nicely when it makes sense to. So step 3, we need to create a database schema. Again, MongoDB doesn't enforce you to keep a schema on the data that you store, which is very excellent, but in the real world, you kind of need to have a schema. So the question of creating a schema comes down to, often in MongoDB, in terms of sort of what are the objects that you want to really store? And that question is sort of what are the natural objects that you want in your database? MongoDB gives you the flexibility to sort of store the objects that are necessary as opposed to the objects that are specified by third normal form. So quick overview of Mongoose and what it is if you missed the keynote talk. It's an object document mapper for MongoDB and Node.js. It provides simple services like schema design and schema validation, as well as convenience objects for mapping to particular MongoDB collections. And it is the mean stack's official best friend. It probably should use its own letter, but well, unfortunately it does not. So the objects that we're going to have in this particular app, you're going to have a food item, which is essentially one food item from the SR25 data set, the USDA nutrition data that we just talked about. A user, because any real API you kind of have to scope by user, and a individual day object. So the food items that a user ate on a given day with associated serving sizes will make things very easy for us to create an API around this using Mongoose and Angular and just the mean stack in general. So First, the nutrition item schema is going to look an awful lot like what we saw before. It's basically going to look like this. The things that really matter are the description, the nutrients array, and the weights array. And Mongoose provides you the ability to declare individual types for each field and validate those types before they're stored. Again, since we're not really going to be adding anything to the SR25 data set, there's really going to be no validation, but this is helpful for sort of structuring the data as it's read out of the database. Slightly more interesting is going to be the user schema is fairly straightforward. All we're going to have is a username. Does it really matter too much what we store with the user? But the day schema is going to be a little bit more interesting. Let me pull that up. Okay. Can you all read that okay? All right. So first, the identifier for a day, it will have an underscore ID, but primarily we will identify it by the date and the user. So what did the Karpov 15 or Val eat on 2014-6/16? And as a matter of fact, we're going to create a unique index on those two fields just to make sure that doesn't happen. And then there's going to be a very big array called foods. The foods will basically define everything that I ate on a given day. Now, there will be a couple of things that are copied from the food item field. So we're going to copy over the description and nutrients from the food items, the weights, and then we're going to create a selected weight object, which is going to point to the weight that the user selected for that particular field, for that particular food item. So in my case, if I specify, say, 2 fillets here, the selected weights field will contain, the index will be the weight in this particular array, so in which case it'll be, say, whatever fillet is, and the amount will be 2. And the nutrient amounts will be the same as they were in food items, so they will be amount per 100 grams. So we'll have to go in and do some multiplication in order to get that to work properly. And to tie this all together, we will use a module called OmniDI, which I maintain. It's really, really cool. Basically, what often goes wrong with people who are using Mongoose for the first time is they do a require at the top of every single file, and then they create the connection, and then they start requiring in all of their schemas and assembling the models in each individual file. And that gets to be messy, especially when you start doing things like, oh, okay, now I have to add authentication to my database because I don't want to give everybody read-write access to my database by default. So then they have to go through each file and change all the function signatures, and it just gets to be a mess. And in addition to that, each Mongoose create collection call opens up 5 new connections to the database, and you might not want 5 connections for every file. So in order to sort of make dealing with Mongoose and dealing with all of these other remote services that we're going to be using a little bit more sane, OmniDI provides you the ability to create these objects once, and then inject them into individual functions by name. So instead of having an express file where, instead of having an express file where or an express route where, instead of just returning an express route, I'm going to have a function that returns an express route that takes a day object. And OmniDI will be smart enough to execute this function for you and say, oh, I know what a day is. I will just put that into the function and take take the return value of that. So how we do that is via the assemble function, which is basically going to go and register by name all of these objects. So it's going to say, can you all read that okay? Or let me pull this up in Sublime Text. This will set up. So I'm going to say, okay, FS is going to be very simple. It's going to be something that's just the result of require FS. Food item is going to be a Mongoose model, which I'm going to create via a factory function. I'm going to require in my schema and return db.model. And once I've done all that, it should be fairly straightforward for us to create an API. Now, creating an API can often be scary, but well, a pun that I couldn't resist is complexity creeps up on you like a snake in the grass, but you've got a Mongoose, so it's okay. So the API routes are going to be fairly straightforward, and often when you're dealing with Mongoose, it's very convenient to sort of define as minimal an API as possible, because Mongoose handles validation for you in a very rich way, as we'll see. So it often makes sense for the client to simply build up a large JavaScript object, and then just send over the JSON to the server and make the server sort of validate everything, instead of having API routes to do things like, okay, let me remove an individual food item from a user's day, or add one, or modify an existing one. All we have is just a single API endpoint to modify a given day for the current logged in user. And the client side is responsible for adding and removing as necessary. Server will just store everything. The other API routes are all gets, and those are basically get a date, search for a food item, and get me information about the current logged in user. So searching for a food item is nice and simple. It looks exactly like what was in the keynote presentation, and also looks an awful lot like the text search query that we executed a little bit earlier. Yeah, that looks like it's readable. Okay, so once again, you need at least Mongoose 3.8.9 to do this. This particular repo uses Mongoose 3.8.12, which is the latest. But so basically, going to get the search parameter and execute a text search on that particular search term. So that looks. If we pull up the express logs, we notice that when I was typing in pink cooked salmon, I got a bunch of API requests that were for as I was typing. But yeah, and the text search API is once again a little bit atypical. There's documentation on the MongoDB website about it if you want to learn more. Loading an individual date. Let me pull that up. Loading an individual date looks something like this, which also, if you're not familiar with Moment, Moment is a very convenient library NPM available module that basically makes JavaScript dates a bit less nasty than they already are. And if you've never used Moment, I would highly recommend trying it. I don't think you'll ever go back to dealing with vanilla JavaScript dates. And frankly, when I went back to Python recently, I was just like, God, how did I ever deal with dates without Moment? Even in Python, it's nasty. But yeah, so this basically creates a UTC date or a UTC moment around whatever the date that the user requested was. Again, if you can't find it, return not found. Oh wait, that should be a 4. This is what I get for hard coding. This is what I get for putting in magic numbers. But so since using Mongoose, we're declaring a list of dependencies. So we're passing in or requesting the day model from Mongoose, and we're going to do a find one for username and the particular date. And so the tricky bit here is this is new field. This basically is a way of telling the client whether or not there is already an existing date for that particular date. So if the user has already saved something or not. That will be convenient for the client side. But for now, all it does is if there isn't one, it creates a default with an empty foods array and passes that back, but tells the user that, oh, by the way, this hasn't been saved yet, so is new is true. And the big scary one is saving a day, but it's actually not that big and not that scary. It's actually considerably simpler than loading a date, because again, Mongoose does schema validation in a very, very sort of deep nested way. So if you recall, the date object, or rather the foods for a specific day, is a very rich and deeply nested structure. It's an array that contains a bunch of objects. Well, Mongoose can actually do validation for you with this $set field. So it will actually make sure that the body data that the user is passing in is something that matches the schema that you've defined. So you're not going to get a user that's saving a selected weights that doesn't match the form that you've declared. So again, all you really have to do here is just, okay, let me take the data and update it. And also one more important thing to notice is that you effectively get access control for free here, because you are only updating the foods subarray or the foods field. So the user can't go in and say, oh, by the way, I'm going to, yes? Question? Oh, question? Interesting question. I don't believe so at the moment. I think you actually have to create a Mongoose document in order to call the document's validate function. However, I think, but internally, this goes through a casting process, which basically tries to match it into the correct form for the associated schema of this particular model. But yeah, so you can just take it as granted that the foods array will match this after it goes through Mongoose, even if you're doing this particular set field. And also, the big scary thing that you don't want to happen is these fields getting modified, because they're sort of a unique identifier. So I don't want somebody basically doing an API put with the wrong username and basically writing food data for somebody else. And you get this access control for free here because you are only modifying the foods field. And this is part of the elegance of writing an API with MongoDB, is you can sort of very easily segment things into, okay, this particular object is actually a parent object for everything that I want the user to be able to edit. And then all I have to do is just modify that particular object, and Mongoose can handle validation for you. So and we're effectively done. There's really no more work to do in terms of the API. It's very pleasant how simple and elegant Mongoose makes writing an API like this. And again, once you have the objects in sort of a neat and elegant structure, becomes very easy for you to define an API around that. And so step 5, let's start using Browserify to build up a client. So question with single page app, and one of the advantages of working with Browserify is how you manage bloated require code or bloated sort of dependencies and script tags in your client. So this is some bad code that I wrote once. You can see it's kind of unmanageable with the fact that there's just a huge amount of different JavaScript files, and it's not clear which JavaScript file relies on which other JavaScript files. So that gets to be bloated and unmanageable very quickly. But what Browserify enables you to do is basically write Node.js style code with requires and put your module dependencies into your package.json file, and never have to deal with CDNs or massive bloated lists of script tags like this. So this is how a simple, can you read that okay? Yeah. So this is how a simple Browserify code or simple Browserify single page app with AngularJS is going to look. AngularJS provides its own routing functionality for single page apps. So what we have here is essentially whenever you're at /, it's going to render a template home, and whenever you're on /track, it will render /track. And the way that works, if you look up here, is actually it's part of the hash parameter for the URL. So when you go to home, it will go to #/ up here. And when you go to track, it will go to #/track. So the page isn't actually reloading, but the internals of the page are changing, and the URL is changing slightly. So how we're going to do this? Well, there's going to be one JavaScript file that we're going to include on the client side. It's going to look like it's going to be this one particular JavaScript /all.js file, and that's going to be built via Browserify. So what's the build process going to look like? Well, the input is going to be basically the client directory, and we're going to run the Browserify command. So Browserify is available, has a nice little binary associated with it that you can run. Well, it's not quite a binary, it's actually a script, but it's an executable. Basically, you're going to run Browserify with -o, which specifies the output file, and specify all the input files. But in order to make that more elegant, as well as not tell your clients to install things with npm install -g, which brief aside on that. Ideally, your module should not require you to do npm install -g. It's necessary for certain modules that are meant to be command line tools, like npm itself or like nodemon. It sort of makes sense. But for build tools like Browserify, it's probably better for you to include the dependency in your package.json, because also it makes it easier for your users to get set up. Because remember, ideally, we want our users to only have to type in npm install, and that does everything that they ever need to do to run that app. And that's where a make file comes in. Probably some of you are familiar with build tools like Gulp and Grunt. Yes, no, maybe so. Well, so Gulp and Grunt are alternative tools that make sort of writing things that you want to do for building and testing code much easier. Makefile is kind of something that C programmers like to use, but on the other hand, it's pretty surprisingly popular in the Node community actually, because one of the alternative uses is it essentially gives you aliases for shell scripts, with the ability to put macros in shell scripts. So it's a sort of much easier version of Gulp and Grunt that requires less global installation, especially if you're already on a Linux or OS X machine. You just have make installed by default. And so what we're going to do with Browserify is we're going to define a rule called build_client, which is going to run Node.js on the Browserify macro, which is the path to Browserify under Node modules, and it does the -o and client star things that we want to do. So in order to compile my UI, all I have to do is run make build client, and you see this command executes. So again, there's no reason why you can't do this with Gulp or Grunt, but I don't know. I like to use makefiles for like very, very simple things like this, because, well, it seems like overkill to write a Grunt file just to run Browserify. So basics, once again, basics of a single page app. Angular is actually included as a dependency in the package.json, or as a dev dependency rather. So we have a dependency on Angular 1.2.10. Angular is also packaged as an NPM module. If you weren't aware of that, it's actually super cool. Unfortunately, there's no NPM module for Angular-route, which is the Angular module that you actually need in order to do single-page app routing. So unfortunately, I had to hard code this into this particular project, but that will be changed soon. And again, yes? Actually, that's a pretty good question. So in order to install Angular, Angular has a dependency on an NPM module called Contextify, which is notoriously very difficult to install in certain platforms. It depends on having the correct version of Python installed, and it depends on having a proper C++ compiler floating around. So in order to install it on Windows, you have to have, say, Microsoft Visual Studio Express 2012 installed in order to get a proper C++ compiler that understands that sort of thing. So for ease of use, it's a dev dependency, and also it depends on how you want to use it. The way that this app is written and the way that I often tend to do things is sort of bending the rule of not committing compiled code and committing the output of Browserify into Git. It's a debatable decision, but it prevents you from having to worry about installing Contextify on your production server, which you may have a different version of Python or something to that effect. So there's a long and a short answer. The long answer is, or the short answer is, Contextify is a pain. The long answer is, Contextify is also a pain. So there's this index.html file that's going to be the base of everything in every single view that we have. Now, essentially there's a navigation bar, all of that, but the magic really happens with this div-ng view thing. For the sake of this talk, you don't really need to know what an AngularJS directive is, but this is a directive that tells Angular to render the particular template in that particular div. So if we actually pull up the Chrome Developer Console, run inspect element, we're going to have this ng view that's going to contain everything that's all of the stuff that you see here. And when you go back here, again, the ng view is there, but the contents of ng view are different. So when you're on the what do you call it, the root route on localhost 3000 // you're going to have this particular HTML, which is basically just a Jumbotron and some very fun CSS that I borrowed from somebody's code pen. Oops. But the real magic sort of happens on the track route, where you're going to have all of this code that's going to actually enable you to search for foods and input and see the foods that you've already entered. Let's move on to the next part. But so the important thing to know is that, or to understand, is like why you would want to do a single page app in the first place. Some people are very much against the idea, but I think that there's some significant advantages. For one thing, you have a bit less server throughput in the sense that your server never has to handle templating, and your server, all it's doing is serving up HTML and serving up JSON responses. So the browser can more effectively parallelize and do things like, okay, render HTML while there's an outstanding JSON request to load more data from the server. There's also cleaner separation of concerns. So your server doesn't have to worry about rendering anything. It doesn't have to worry about is it going to crash because the templating parameters are wrong. You're just outputting JSON and outputting a simple HTML file. And also, in some regards, you're getting less bandwidth usage, because whenever the user tries to go to a new page, say whenever I'm going between here and here, the HTML is only loaded once. So while this window is open, I don't actually, let me demo this from the network tab. So everything has been loaded. When I hit track, it makes a request for track.html. When I go back to home, it doesn't make any request for home.html. When I go back to track again, it's just going to make a JSON request and not re-request track, because Angular is going to cache the actual HTML that it needs to template that particular view. So you only have to transfer that once. And then after that, all you have to do is worry about transporting the JSON, which is relatively inexpensive. Also, it gives you more control over the UX, because again, the transition between views happens in JavaScript as opposed to happening on the page layer. So you can do things like show animations while the page is loading. So you can have a nice little swipe left effect when the user clicks on something, when the user clicks on a link, in order to sort of make your app look really cool and really slick. That's outside, that particular thing is kind of outside the scope of this presentation, but it's definitely possible, and you're more than encouraged to look into it. So for step 6, let's go ahead and let's build an actual client for doing the tracking, or for doing our food tracking. So we're going to create an AngularJS controller that's going to talk to our server. Again, since this is mostly a server-side talk, I'm not going to go too much into the details of Angular, but the way that you should probably think about Angular, or the way that I like to think about Angular, is that an AngularJS controller provides an API to the HTML in order to sort of do particular server interactions and computations. So in that way, Angular provides you a very clean separation of concerns, where you have you put on your JavaScript developer hat and you start writing a bunch of code that does, okay, I'm going to get this, I'm going to make this GET request to the server. I'm going to get this data, I'm going to transform it a little bit, and then I'm done. And then you can put on your designer hat and say, okay, so I have this data, let me go and sort of, okay, I need like one div for each particular item in this array. I need to render this one particular object. And when the user clicks on this, I want this to happen, or this particular API call to happen. So let's do one quick modification to the module itself, or the module code, which is we're going to define a controller for the particular view. Now, Angular's templating is pretty good about this and lets you sort of swap out controllers for each individual view. So right here we have this one particular track controller.js file, which is going to define the controller for the track route. And since home doesn't really do anything useful, we're just going to define one for track. So the general track controller structure is going to look like this. It's nice, it's Node written, or since it's browserify, it's Node-like code. It has its requires. Moment is installed as a dependency in package.json, and calculations is going to be a separate file that we're going to use in a code sharing context. So some of the things that we want to be able to compute when we're just for displaying things like counting calories, those don't really match exactly with the data that we have. Again, one of the things that you'll see a lot when you're writing Mongoose code is the client and mean stack code in general, is that the data that's served up to the client can pretty easily just be transformed into whatever is necessary. So whenever the data gets loaded, may not be in the exact format that you need, but it's helpful for the client to be able to modify it, and also for the server to be able to modify it in certain contexts. So the track controller is going to take in a bunch of things via AngularJS's dependency injection. It's going to take in, an HTTP object in order to be able to do HTTP requests. So it's going to have an API that looks something like this, which may be a little bit difficult to read, but doesn't really matter about the particulars. All that matters is there are a bunch of functions that you are able to call from directly from your HTML and do things like, okay, let me get this one, let's say, the ability to load a date, or the ability to search for a food item, or the ability to save a date. So let's see how we're going to use that. Well, so for adding a new food, whenever I start typing something like sockeye salmon, I'm going to have a bunch of handy little directives, which are essentially how AngularJS interact, or how the tools that AngularJS provides you in HTML in order to interface with your JavaScript API. So whenever this particular input field changes, I'm going to send a search, or I'm going to call the search function, which internally is going to do a server request. And I'm going to have a div which repeats for every single search result. And whenever you click on one of these divs, you call the add food JavaScript API call, and that takes care of adding all of the food items. So let's take a look at implementation of one of these API or one of these HTML API calls. Track controller. So here's this one particular load day function. Essentially, all it's going to do is do an HTTP request to the server and update a bunch of internal variables. So things like the current day is going to be whatever the server-side API said it was, and we're also going to run a recalculate function, which we're going to talk about right now. Well, so the recalculate function is actually all it's going to do is call something from the calculations file that we included here, which is actually going to be shared between the client and the server because it's under the /common module or under the /common folder. And now the implementation of calculations.js, let's take a look at that. And essentially, well, so this code can be shared between the client and the server. Doesn't do any file reads or anything to that effect. But all it does is essentially some of these things that we want to display, like the omega-6 to omega-3 fatty acid ratio, which is a very complex calculation. We just want to put it in a place where it can be accessed by both the client and the server. Okay, so that's kind of how our single page app is going to work. Again, code sharing becomes very easy with Browserify, and general rule about how you do things with the mean stack is that the objects that your server deals with, the objects that your client deals with, and the things that are stored in your database should look pretty similar. So the object that appears on the client side on the day field should be pretty much the exact same thing as a day that's stored on the server side or in the database. And you have this common code that provides you common computations on those particular objects. And same objects gives you very easy code sharing, and it makes it easier for you to go in and debug because you know, okay, I don't really have to worry about how this object is getting transformed over to the database or over to the server. Let's see. Talk a little bit about the search call, the add food call. Well, let's just move on to the testing side of things. And well, one of my favorite things about testing is the fact that you can get non-cat reporting using the Mocha framework, using the -r non-output. So you can have a nice little kitten when your tests succeed and a sad kitten when your tests fail, which is very important. This is the most important part of this talk. Yes, exactly. But anyway, so getting serious for a little bit. So I believe that, especially in the mean stack, unit tests are essentially one of the key for building good code. They help you ensure good code quality by helping you think rigorously about your code's dependencies and assumptions. And they help provide a basis for your NPM test output to actually be sort of a valid way of outputting is your code correct or not. And well, grunt, makefile, doesn't matter which one you use, but just use one in order to actually run your tests. And given that this is a food app, I often like to liken writing unit tests to eating your broccoli. Sure, you know, maybe it's not the tastiest thing in the world, but if you want your code base to grow up big and strong, write your unit tests. So, one of the reasons why OmniDI is so important is that it gives you very easy control over how much to stub out, and depends on how you like to write your tests. But I believe very strongly in mock stubbing out everything for unit tests. So, And dependency injection makes this super easy because, well, when you're writing out, whenever you're writing your code, you already have all of your dependencies listed in the particular function, so you don't have any global state, no need for spies, nothing like that. All you have to do is just call that function with a different set of dependencies. You can actually, one of the things that I usually like to do is create a separate dependency injector for testing. That includes stubbed out versions of every module that or every service that I want to depend on. So here's a simple test case for testing the put route for saving a date. So for describing, we're going to use Mocha, which is a nice sort of behavior-driven development style testing framework for Node.js, written by, once again, the same dude who wrote Express, the good old TJ. Here's a test that's going to cover basically just saving a date. So we're going to, once again, we're going to have this this DI object that we're going to create in the before each function. So we're going to each time create a new set of stubbed out stubbed out objects for testing purposes. And we're going to inject, or what's his name? There we go. So we're going to actually create the route function by calling inject on that on the put route, which only depends on day. But it's going to pass in the stubbed out day function and return the actual express route. And then we're going to call that express route on a stubbed out request object and a stubbed out response object, and then run a bunch of asserts to make sure that everything worked as expected. So let's see that in action. Let me recall what okay. Make test, and now we have a happy kitten, which is great. And one of the beauties of using Browserify is, once again, you can write your client-side tests the same way that you write your server-side tests. Client-side tests have a slightly different set of requirements in the sense that not all browsers run JavaScript the same way, but for the purposes of providing quick validation that your client-side code is correct, it's great to just run your client-side code through Node.js, because, well, Node.js kind of loosely operates the way that Chrome does on JavaScript. And of course, everybody knows that Chrome is the only browser that matters, right? Well, pretend I did say that, but, well, yeah, Chrome is a good starting point. So in this case, you have the ability to sort of test your track controller with a stubbed out HTTP function, and basically nice little BDD style for making sure that everything that should be exposed to the client is exposed to should be exposed to the HTML is exposed to the HTML. And here's just a simple unit test for track controller. The basically stubbed out response that says that whenever you do an HTTP response to API day yesterday, return this object. Create a track controller with everything with a vanilla scope object and the stubbed out HTTP object, and call the previous date function and make sure that, again, track controller did the right thing. It sent a request to the right API route and exposed the correct things to the HTML. And as you saw just before, I can very easily tie tests together with using makefile. But the interesting thing here is, so Grunt provides you a nice way of watching a file or watching a set of files, basically rerunning your tests every single time a file changes. Gives you nice output. But, well, nice thing about Mocha is that it has its own -w flag. So again, we still don't need to use Grunt. We can just use Mocha's -w flag, and can do things like make test watch. So it's going to be watching. We have a happy kitten. Now let's see if we can break something. So let's say that we're just going to comment this out, and oh, boo, that's a sad kitten. Where's the sad kitten? Oh, see, the kitten's knocked out. It sucks. And so just to recap, Browserify gives you some great advantages for testing in terms of code sharing and in terms of giving you a single testing framework for sort of running nice stubbed out tests for all of your code. And one more quick step, which I know I've been talking for quite a long time, and I know you're probably getting quite tired of this, but one last thing is talking about authentication with single page apps. It's something that always trips people up. So authentication, it's really easy when you use Passport, but of course you have to have a redirect, which may or may not be the correct behavior for your app. In this case, yeah, just whatever. Don't care about it. Might as well use a redirect. If you really want it to be part of your UX, it's slightly trickier. You have to again bake your own stuff. But well, if you're willing to tolerate the redirect, you can do it the same way that you normally would with Passport. Just make sure that you redirect users to the right place. But the more tricky bit is handling the cases where the user hits the API but isn't logged in. So both the client and the server have to be able to handle that particular corner case. So for app.js with Passport, pretty straightforward. I'm sure the mean guys will talk your ears off about, or the mean.io and mean.js guys will talk your ears off about using Passport. But just simple stuff. We have a cookie that's going to last for a week. That's going to determine what the user's session is, and this is basically all the setup you have to do in order to use Passport. In addition to adding a couple of middlewares and routes. So check login middleware, just fairly simple. Gives you a 401 not author or HTTP 401 not authorized, and tells you to go to auth Twitter if you're not logged in. Otherwise, just go on to the next thing. And again, track controller needs to be modified a little bit to make sure that if the data has a redirect field, or if error returns something that contains a redirect field, we just redirect to that particular URL. And a little bit of, well, I lied. There's more Passport setup to be done. But what this is going to do, just create a Twitter strategy and two fields that are quite important. Where is this code? Aha. Okay. The two functions that you always have to implement with a Passport implementation is serialize user and deserialize user. These functions do kind of what they sound like, which is basically give me a unique identifier for the user and then give me a user back from a unique identifier. So for us, we'll just implement those with just MongoDB's user ID or _ID field. And we're going to create one more controller that's going to be included in index.html here. Or no, it's actually going to be part of all.js, my mistake. But it's going to be above all other controllers in the scope. And this controller is going to look something like what you see up here when the thing is done loading, or not. But it's going to create it's going to just define an object called scope.user, which is going to give you the ability to check what the current logged in user is, and the ability to query for, okay, who's the currently logged in user by pinging the /b route that we already defined, and also be able to reload it every I guess 60 minutes, which seems like a reasonable default. And for displaying the logged in user, it's fairly straightforward. It's going to be what looks over here. So again, that's my Twitter handle. That's going to show up right over here. again, using the handlebars notation that AngularJS likes to use. So that's everything that we're going to talk about in terms of building out this application. Again, you're very much welcome to pull down the application off of GitHub. It's available on my GitHub. You can go around, play around with it. Again, review of what we learned: single page app with the bean stack using AngularJS for routing, and Browserify for building code building browser code from Node modules. Using Twitter OAuth, and of course using some very elegant MongoDB features such as text search in order to construct a fairly sophisticated app in a fairly short period of time. And of course, Mongoose gave us a very simple, very elegant API that we really didn't have to do much work for, and MongoDB 2.6 text search made the ability to search for food items very nice and simple. So thank you guys very much for listening. I'll take questions like right about now, but my Twitter is @CodeBarbarian. There's also my slide share. All of the slides from this talk are up there, and all this content is up on GitHub. Here's the link once again, and I also have a blog post on the data set and sort of a deeper dive into what's going on with that particular data set. So thank you guys very much.